industry.
I just saw you. Yeah, we're live now.
We
All
are
right.
live.
Yeah.
Okay. Thank you, everybody. We had a couple of technical difficulties to work out. I would like to welcome y'all to the August meeting of the Warren Astronomical Society. We are still virtual, as you can see, and we'll be talking about that. But first off, I would like to kick things off with a little bit of news update. All right, so we've got in the news. So first off, the ISS had a pretty eventful time of it this past week, and not in a good way. So the new Russian module Nauka, seen here, was added successfully to the ISS, but within a couple of hours of its attachment, things got rocky in a way that, if you're familiar with the mission Gemini 8, where they docked with the Agena and went spinning out of control, it's a little reminiscent of that. Nauka began firing its propulsion thrusters, sending the entire space station off kilter. After this was corrected with loss of attitude control procedures. Again, memories of the Apollo era here. That's a contingency that astronauts and flight controllers train for. In concert with the flight controllers in Moscow, the Houston team commanded the station to fire the thrusters on the Russian segment, as well as on the Progress supply vehicle then attached to the station. The combined actions prevented it from tumbling too violently until Nauka ran out of fuel. Quite dramatic. Following this near miss, NASA hastily called a news conference, but they deferred many questions on the technical issues to Roscosmos, which has offered mixed messages. Senior official in Roscosmos, former cosmonaut Vladimir Solyov, said in an official statement, due to short-term software failure, a direct command was mistakenly implemented to turn on the module's engines for withdrawal, which led to some modification of the orientation of the complex as a whole. Sounds like a software error, but later the head of Roscosmos, Dmitry Rogozin, acknowledged there may have been a human factor involved. Friendly reminder, it's rocket science, and mistakes can kill people. Well, if you had any doubts about Einstein's general theory of relativity, astronomers have added another piece of evidence to the pile. Light from behind a massive black hole has been detected for the first time using the European Space Agency's XMM Newton, their largest satellite, and NASA's New Star Space Telescope. Researchers observed the black hole flinging X-rays out into the universe. This black hole is about 10 million times more massive than the Sun, located in the center of a spiral galaxy called 1 Zwicky, a cool 1,800 million light years away from Earth. That's how you know the Europeans did the transcription, because they have thousands of millions, 18,000 million. After observing a series of bright flares of X-rays, they noticed smaller, later echoes of light consistent with X-rays reflected from behind a black hole. How does that happen? Light does this. This is a simulation made by the Goddard Space Flight Center. The light wraps around. So lead author Dan Wilkins says any light that goes into that black hole doesn't come out, so we shouldn't be able to see anything behind it. But the black hole warp space bends light, twists the magnetic fields around itself. So this 3D map shows how it kind of loops out so that one can see the echoes. This is something predicted by Einstein back in 1916, but never confirmed until now. Wilkins and his team want to use that technique, to create a 3D map of a black hole and figure out how the corona produced such bright X-ray flares. The ESA ushered in a new era of communication satellites with a Eutelsat Quantum, launched aboard an Ariane 5 rocket from French Guiana on Friday. Unlike conventional satellites, which have been hardwired on Earth and cannot be repurposed once in orbit, the Eutelsat Quantum is fully reprogrammable. It allows users to tailor communications to their needs almost in real time as it orbits 35,000 kilometers above Earth, meaning it can respond to changing demands for data transmission and security protocols during its 15-year lifetime. And CERN is up to its tricks. They've found another exotic particle, a new one called PCC+, which sounds like some kind of antibody, also known as a tau tetraquark. It's the longest-lived exotic particle ever discovered by this or any other atom-smashing device, and the first to contain 2 heavy quarks and 2 light antiquarks. So this tetraquark is, it decays into particles easy to detect and puts out a distinctive energy trace that allows for excellent precision measurements of its mass and allows the study of the quantum numbers. I am not a physicist, and I defer to any physicists who want to talk about this further. I saw some articles calling this yet another God particle, which is kind of sketch terminology. Anyway, it's exciting, it's new, and it's maybe the most significant thing that they've found since the Higgs boson itself. Yay, CERN. In the sky, you may have seen a email blast coming out. Our sharp-eyed member, Mark Jacobson, let us know not only is Saturn at opposition, but this is ideal viewing conditions this week. The jet stream is tame. Saturn and its moons are at a favorable angle. This picture from 2018 is, I think, the reverse of what we would be seeing now as far as the tilt of the rings. But if you've seen Saturn recently, you'll have seen, this great view of the rings, the divisions plainly visible, a nice 3-dimensional pop to it, and a plethora of moons. So Saturn reaches its brightest point 2 a.m. Eastern Daylight Time on Monday, so that was today. Its highest in the sky around midnight, our local time, located in Capricornus. The rings are at a lovely 18-degree angle with respect to Earth. And if you're not familiar with Capricornus, it's this boomerang shape hanging low over the horizon. Saturn is accompanied by the usual suspects, so Rhea, Janus, Mimas, Tethys, and Enceladus, and of course, Titan, which is often mistaken for a little star. So, as Mark Jacobson said, dark skies, good clarity, our own moon out of the way, perfect opportunity for an impromptu vacation. Finally, it's that time for real. The peak of the summer, the most hyped meteor shower of the year, seen here in a glorious photograph from NPR. It is Perseids time. And it is a Wednesday, which is super inconvenient, but Michigan's dark sky parks are all hosting events. I will rattle them off to you now, and I will post that link here in the chat. If you want to have a good time somewhere in a dark sky, they will be doing things at Hartwick Pines, Meteors and S'mores, at Ludington State Park, up in the Porcupine Mountains, at Quamanon Falls, at Muskegon State Park, and at the Waterloo Recreation Area. So I'll let Rhea talk about whatever we've got planned for that night, but if you want to do some driving, all of those state parks are having a dark sky event that night. And that concludes this issue of In the News. All right. Whoops. Okay. So welcome again. I see we've had a few more people join us. That's great. Presidential report. The Delta variant has disrupted our planned return to our venues. We are regularly fielding questions for members of the public. When are you going to go back to Stargate? When are you going to go back to Cranbrook? When can we come to Macomb? I know people are anxious to get out and about, but do not have an official return date to either Cranbrook or Macomb right now. We will discuss the picnic thing in a second. All I can tell y'all, get vaccinated, encourage everybody to get vaccinated. Michigan's numbers have not been great. We've not been the worst state by a long shot. We're definitely not anywhere near the best. So get those shots in arms and cross your fingers that a vaccine will be approved for small children, because we would love to be able to go back to schools, go back to libraries. Not happening until we feel safe doing so. And I see people with small kids at home nodding their heads because it is real. Okay, so I promised I would talk about the picnic. In light of the Delta variant, the board voted unanimously tonight to convert the planned picnic to a virtual event. We had talked about the possibility of requiring masks. Again, we have not been successful in even getting people to comply with flashlight ordinances. And frankly, we should be a group of colleagues, not the masked police, and we would hope that people would be able to respect the health and safety of their fellow astronomers. Since that is not always the case, and we do have members who have health issues, we do have members whose family members have health issues, and we have members with small children at home who cannot yet receive the vaccine in any event. So, out of caution, we are postponing the picnic and converting it to a digital event whose details we will be putting about on the MailChimp blast soon. We are very sorry about this, but the board has been looking long and hard at it, reevaluating it every step of the way during the course of the summer, and we didn't really have a good alternative. We're about fun and we're about science, and we're not about getting people sick. So, very sorry to break that news, but that was the decision tonight, and well, 2022 is only a few months away. In other news, the September meeting will be on the second Monday of the month, as it is traditional to postpone the meeting from Labor Day. So the September meeting for Cranbrook will be on the 13th. Yes, it's the same week as the virtual Macomb meeting. That happens in September. And we will be calling for people to step forward for the nominating and election committee, because we're only 3 months out from board officer elections. If you are interested in being on the committee or interested in being on the board, please let us know. Okay, and with that, I will pass things to Dr. Dale Partin.
Okay, thank you, Diane. At our next meeting on August 19, Matt Dietrich will give the main presentation. His topic will be plane wave instruments, exploring their astronomical offerings. If you don't know, Plane Wave Instruments is a company in Michigan, out beyond Ann Arbor, that makes telescopes. Up to 1 meter aperture, and they have plans to go to 2 meters, but they also make smaller ones, of course. So I visited that company a year or so back, maybe it was 2 years ago. Quite interesting. I look forward to that presentation. Then a month from now, at our meeting on September 13, Jim Shedlowski will give the main presentation on the Giant Magellan Telescope that the U.S. is the main sponsor of down in Chile. It'll be one of the 3 ultra uber observatories that are currently being built. And he will mention the other 2 to some extent. Our short presentation on September 13 will be given by Gary Ross, called Hubble and the Known Universe. I don't want to give it away, but we will hear from Hubble himself. Okay, so quite interesting. Don't miss it. We will hear from Hubble himself. Beyond that, I'm always looking for speakers. We're booked up this year, but it's not too early to start thinking about giving a presentation next year. Please, please, please let me know if you're interested either in giving a full-length presentation or a short one. Also, we're wanting to have a special event where we would have several speakers, each speaking briefly on what were some early experiences in astronomy that got you involved in it. That should be a fun kind of thing. And you may be getting a survey asking you about that. So just giving you a heads up if you get a survey. I think that's it for now. Diane, back to you.
Thank you, Dale. And I will now pass the baton to Riyadh, our second vice president.
Thank you, Diane, and hello, everyone. I visited the observatory on July 23rd. All the equipment and buildings are in good condition. And as Diane mentioned, fortunately, we had decided to, for now, postpone and cancel this picnic, but maybe move it to a virtual event. So one of the things that we've talked about that we have for a while is if Doug is going to available, usually the Northern Cross Observatory will have basically a virtual session place our open house, which is on the 28th, same day. And there may be, as that also, there may be a possibility of other virtual events. Other than that, we'll see how that's going to go. Other than that, everything else is fine. We're basically looking forward. Hopefully, when the pandemic is over and it's safe for us to invite people back to the observatory, then we will do that. In the meantime, on the basically on the 11th or the Wednesday in this month, what I'd like to do is it's not an event of the Astronomical Society. I personally was going to see if I can make it to the observatory at night. Maybe I can look at basically observe the Perseids meteor shower. So whether I make it or not, I am not really sure at this time because I'm actually working in Kalamazoo right now. However, people are the site is open and people to go there. And if the guard stops you or if there's somebody there that comes in there, you have to leave. Please just let them know you're with the Astronomical Society, but they're the meteor shower. Now, if they insist that we leave, then please don't argue. We have to leave. Other than that, you could probably just go there and that along with the other locations that Diane mentioned in the other parks. Again, this is not an official event, but I'd like to personally, I was going to try to be there if I can make it. So that's all I have right now at this time. Back to you.
Thank you, Riyadh. And since Riyadh had a kind of a spotty connection, just to reiterate, Riyadh plans to be at Stargate on the 11th for an unofficial, not publicized, casual, let's see if there's meteors. You're welcome to come. If you are asked to leave by the Metro Parks Police, comply. We're not going to kick up a fuss at this time. This is not a publicized event. We're not putting out an email blast about it. Just understanding, hey, we've got this spot. We do have the right to be there as members. We're not going to kick up a fuss, but it'd be a cool thing to see. Otherwise, the state parks have multiple dark sky events going on that we encourage everybody to check out because they will also have food. Okay, thank you, Riyadh. And Mark Kedzier, Secretary's Desk.
Good evening, everyone. The minutes of the July meetings of the Warren Astronomical Society are in our award-winning publication, The WASP, and hope you enjoyed reading it. I did. And that's all I have to say. Thank you.
Thank you, Mark. Adrian at Treasury. You're muted.
I'm usually good at not muting myself, so unlike me, the Treasury is pretty stable. We have had 2 new members, and I wanted to read their names. I didn't see them connected, but we've welcomed Clifford Lockhart and Joseph DeStefaniis to our, bringing the totals to 179. It seems we've been in the 170s for a while. So in the account, I give rough numbers, $22,000. The Glack account has not moved. Glack hasn't yet asked to transfer funds, so we're still at $3,000, a little over $3,000 there. We are up to over $700 in the PayPal account. Now our account does get things from a PayPal giving fund and other other charitable sources of income. It's not very much, but it helps us maintain a working balance, which in hopefully the near future we would be able to use at an in-person event. So we would be prepared for that. And the other thing I'll throw out to the club is that we know we're talking about nominations for office, and I'm hereby nominating myself to continue with the Treasury for another year. So with that, that is the end of my report.
Awesome. Thank you, Adrian. And yeah, at this rate, when we return to in-person events, I think I'm going to take up Phil Martin on his old challenge to buy everybody steaks, because this is getting ridiculous. Okay.
We certainly have enough money in the Treasury to do so.
Yeah. We are also,
You probably shouldn't use it for that.
well, we are also talking about the long-delayed Stargate expansion to a 3rd building, so we're hoping that we can keep y'all abreast of some good things there, since that is what a good chunk of that money was for in the first place. Okay, Bob Tremblay at Outreach.
All right, we are getting more requests coming in from libraries, and I'm going to be sending out an email to libraries, saying that, hey, we've got members that can do remote presentations, and I'm going to be getting them a list of what we can get them. So you can be expecting to see a lot more. So I'll be sending emails out to the outreach team, but requests are coming in, so just be prepared. As for elections, I am being term limited out, so we need a new outreach officer this year. So if you're interested in this position, we need to know about that, or we'll nominate someone who's maybe not interested in this position. But so anything else? I've got something from Mark Musen. He's a guy who used to work at Starbase One, came and talked to us. He's now working at my wife's intermediate school district. There is some sort of, there's a teacher who's working in the lower, like 3, 4, fourth grade, who wants to do an astronomy program this year. I mean, I've not had time to look at it. I was on vacation last week, so I'll be sending something to the board about this. So if anybody has any experience working with the younger set, we might need some help with that because sometimes they're difficult. Yeah, sometimes they're difficult to work with. Other than that, I think that's it for outreach.
Thank you, Bob. And Dale Timmy, award-winning editor of the award-winning WASP.
Thank you, Diane. First off, I want to say greetings from sunny Pennsylvania right now. We're in a lovely Airbnb. Be here for a week. And I also managed to get the WASP up before we left town, so pretty happy about that. And come August 19th, they'll be officially recognizing my award for the Astronomical League. So another thing to look forward to. That's my report.
All right. You can throw up that picture yourself with the plaque anytime you like, Dale. So that concludes our officer reports. We will now visit the subgroup reports. I do not see Solar Marty, Bob, Ken, any of our stargazers. Bob's got his hand up. What would you like to say about the sun?
Okay, well, I'll be sharing this here if I can figure out how. Can I share that? We got a sunspot, which is pretty cool. Let's see, screen one. Share it. Are we seeing a sunspot?
Yes.
All right,
Yes, we
so
are.
there is a sunspot. That's a pretty big one. And when it comes to videos, there's the chromosphere. We've got some pretty cool prominences going on. Starting to see more and more of these as the solar maximum is starting to take effect. And let's get over to, get out of there, share button. This is the corona. It's supposed to be animated. Thank you. Real hot spot there, moving out over on the right. And what's really odd is where that sunspot is, there is some activity down there in the lower left. So where the sunspots are, but that thing on the right is really cool, but the corona is pretty cool. So we've got a sunspot anyway, and some activity. I've saw there was a post, NASA's visualization studio had a post on today when I was going to these things, talking about our aging instruments in space, and they were showing the degradation in data coming from the SDO, and I'm like, yeah, so that's kind of scary.
All right. Double star subgroup, Riyadh.
Yeah, thanks, Dan. Basically, what we've been doing is during the virtual open house events through the Northern Cross Observatory with Doug Bog, we've been going through sometimes, asking attendees to basically give us a list or ask for what objects they would like to look at. And then Doug, if it's easily accessible to his telescope, Doug would basically point the telescope at it, and we look at these objects. So a couple of times we've looked at double stars, and a few other times we were trying to investigate a couple of stars if they were actually carbon stars because of the colors that they had. So it's kind of a lot of fun. Sometimes we're doing this on the fly. So I suspect if the 28th is going to be clear and we're going to have an open house again, a virtual open house again, then we may be able to look at more of these double stars, carbon stars, and other objects of interest, including a couple of times we've looked at quasars as well. Thank you.
Thank you. Okay, astrophotography. I don't see Bill Beers. Adrian, you got anything briefly?
Yes. smoke is still plaguing our skies from time to time. I will share two images. As you may all know, I tend to do more nightscape type astrophotography as opposed to classic astrophotography. I will go ahead and share screen. I get to share screen too because I recently added a new screen. So a couple pictures that I'll share that sort of highlight what's going on in the night sky. It may be tough to see the night sky, but you have to be patient, just as I'm trying to be patient with myself and find the images I want to share. Okay, so when smoke is when there's smoke, you get an image like this where you've got haze. This is actually the Milky Way, but you can barely see it. So it is tough. You can shoot at objects in the zenith, like Cygnus, which is in all of the objects up there, like a North American nebula. Aim your cameras, telescopes up there. Even through hazy smoke, you can take some frames and gather some images there. The Crescent Nebula has been very popular. Moonrises come in particularly red. Now, this is a composite shot that I tried to make the moon look as natural as I saw it as it rises. It stays the red for quite a while, even as it rises up above the horizon, till it gets to about 20 degrees or so before it finally begins turning white. If there's heavy smoke at night, it stays that reddish color while it's in the sky. If you go to a dark site that's Bortle 3 or more, you might get lucky and you might see some stars, and then you can get a decent Milky Way photo. This is the Point O'Bark Lighthouse in the Thumb, one of the dark sky places that you can go if you've got pretty good skies. When it's a little bit hazy out, it goes down to about Bortle 4, which is what I was thinking when I looked up and I ended up taking this picture. So as far as astro photos go, the forecasts are looking pretty good, but they're kind of spotty in places. And so if you do go, you know, if we get a good night, definitely head out. This is 2 years ago, a Perseid next to the Milky Way. This is a photo one of my earlier photos that I took where I got extremely lucky to catch a Perseid. They are all around. There were 2 or 3 more fireballs like this that we saw that I didn't have the camera pointed to. I didn't actually see this fireball with my eyes, but I did have someone say, "Hey, did you see that meteor?" And I go, "Where?" And I look on my camera in the back and I noticed that I caught this. This picture ended up making a calendar at my job. So with that, I'll give see if I can stop the sharing here. Give the floor back to Diane or anyone else who has any astrophotography observations to share.
Yeah, well, since Bill's not on, I think we'll keep on going with the other subgroups. So thank you for the lovely pictures, Adrian. All right, Astronomical League. Actually, that's you again, Adrian.
All right, so August 19th through the 21st, I am gonna go and try, or just to make it quick, read the WASP, because the Astronomical League information about the online conference is in the WASP. Our esteemed member David Levy is one of the speakers for ALCon. You do not want to miss his poetry, his vivid recollection of the night sky, and anything else he will share with us. There's also David Eicher will be there, and a whole host of other nationally recognized professional astronomers, amateurs that are in the field, and many other guests. There will be door prizes. Global Star Party is where the Astronomical League they ask questions for folks that are that go to the Global Star Party, and I'll put the link in the chat for that. It's every Tuesday. We've got a couple more weeks before the ALCon starts, the online Astronomical League convention starts, and there are a lot of door prizes, including telescope gear, binoculars. The prize list keeps growing as donations keep coming in. So for a chance to win those door prizes during the Astronomical League event, I'll put it in chat in both YouTube and here on the WebEx. And if you can come to any of the days, especially the opening day, come to watch Dale Timmy receive his award and be recognized, and come see David Levy and all of the other speakers that we have. If you can make it out, we would love to have you. And the disclaimer the Astronomical League always gives: if you look at the sun, please be careful, use approved eyewear only. Do not look at the sun directly, or serious damage to your eyes can result. Even me, who takes a bunch of pictures of the sun. So with that, that is my AL report.
All right. And finally, what's going on with Glack? I see Bob is taking a coffee break. So that's you again, Adrian.
I need a new hat for Glack. I have several of them. So, and again, attempting to make it short, Glack had voted to have an in-person event. In light of the announcement you just heard from the Warren Astronomical Society, and that we're postponing the picnic, other astronomy groups are kind of all over the map with it, but there's no denying that as the fall is coming along, businesses are requiring masks again. You're seeing it around the country where masking mandates are beginning to ramp up again. Glack will have a discussion about this and determine if, even if we try and mandate mask wearing and social distancing, are we going to be able to do that in light of the attitudes that do still exist? I offered, take a look at the growing rates and notice how the rates look in the South as compared to some of the states that have begun to put mandates in place again. Michigan is doing better, but there are cases haven't gone down. So Glack will be looking into that and making a decision and discussing it a little further. We don't know yet if we have time to organize an online event, but we will discuss that as well. So
All
that's it
right.
for the Glack report.
Thank you, Adrian. And only have a couple of minutes here from observing reports. Do we have any? I see David Levy's hand up.
Well, thank you. Thank you, Diane. And again, Adrian, I really enjoyed looking at your pictures. All I can say is looking at your pictures is like listening to Mozart. Anyway, I have some observing news. The sky has cleared for a few days here in Arizona. And I've been out observing and doing some comet hunting, and hopefully I'll be able to see some Perseids next week. When I was an undergraduate student at Acadia University, coincidentally, today I was out looking at the sun. I did not see that new sunspot group, but I will try again tomorrow. And I wasn't seeing any prominences. And then I got this brilliant idea, this Nobel Prize winning idea, that maybe I should try focusing the telescope for the prominences, which I did. And suddenly I was able to get 10 prominences today. Anyway, back to Acadia. When I was a student there, I really fell in love with the works of Henry David Thoreau. And in those days, I was more interested in him than I was in his closest friend, Ralph Waldo Emerson. But in recent years, as I've gotten older, I'm finding that Emerson's writing is less formal, less structured than that of Thoreau, and also more personal. And so my quotation for you today is going to be from Ralph Waldo Emerson, 1836's essay on nature. To go into solitude, someone needs to retire as much from his chamber as from society. I am not solitary whilst I read and write, but nobody is with me. But if someone would be alone, let him look at the stars. The rays that come from those heavenly worlds will separate between him and what he touches. One might think the atmosphere was made transparent with this design to give us in the heavenly bodies the perpetual presence of the sublime. Seen in the streets of cities, how great they are. And here is the key. If the stars should appear one night in 1,000 years, how would we believe and adore and preserve for many generations the remembrance of the city of God which has been shown? But every night come out these envoys of beauty and light the universe with their admonishing smile. Thank you, and back to you, Diane.
Thank you, David. Any other observing reports? Dale Timmy.
Yeah, I've observed the arrival of the Astronomical Award.
Yay! All right, beautiful. That's observing.
Yep,
Very
traveled
nice.
all the way from Florida with me.
Very cool. Well, I finally made it up to our dark sky site after I think it had been about 7 weeks. We had a moon playing havoc with us, and we had the haze from the western wildfires, but we did get to have a few nice little views of Saturn and its moons, Jupiter and its moons, and actually a really good view of a gibbous moon that had a pretty stunning terminator. So not quite full. The shadows still in surprising relief. The haze meant that we didn't use a filter, and it was really quite incredible. So it was probably the most pleasing, almost full moon observing I've ever done. We were just using the 8-inch Dob, but it was really good. So I see Catherine's got in the chat, I saw Saturn. It's a small deal, but a big deal because it's the first time I saw it through my telescope. It's an old 60 millimeter, and the only eyepiece that isn't currently missing pieces is my 20 millimeter. So Saturn was a tiny elliptical dot, but if I looked closely enough, I could just barely see the gap between planet and rings. That was pretty cool. Yeah, it's a cool moment. Any other observing reports before we do the short talk?
Hey, Diana, I don't have an observing report, but just a suggestion that everybody get out possibly tonight or within the next few days to observe the Seeliger effect, or I forget what else it's called. It's like a surge or something like that. But basically, it's the dramatic brightening of Saturn's rings when it's at or near opposition due to the reduction of the shadows that are cast by an oblique sun and forward scattering effect. So it's pretty neat to see the rings brighten so much around opposition.
Nice. Thank you for explaining that bit, Mark. Okay, so go see Saturn, but in the meantime, we've got our short talk, and I will hand the baton back to Dr. Dale Partin to introduce our guest, who is very familiar to y'all.
Yes.
Dale.
Thank you, Diane. Tonight, Bob Tremblay will give our short presentation. He's a member of the board in charge of outreach. Hopefully that outreach activity will be ramping up if we can get past COVID. Bob has special astronomical interests in asteroids, near-Earth objects, and meteorites. He's also a fan of various space-related software, such as NASA's Eyes on the Solar System, and I think he's in love with Kerbal Space Program. He's a solar system ambassador for NASA. He and his wife, Constance, who is a middle school science teacher, but the two of them together run an after-school astronomy and space science club at Connie's school called the Endeavor Space Academy. I mean, what isn't he doing? He's also, I forget what it is he does for the Vatican, but something, the Vatican Observatory, something important. His topic tonight is what makes you say, wow, when it comes to astronomy. Oh, and did I forget to say, he gives really nice presentations. Bob, it's yours.
Testing, testing. You hear me?
Yes.
All right. So when Dale suggested this presentation could be a full-length one, and he's right. And what I've done with this presentation is take dozens of topics that could themselves all be full-length presentations, and I'm going to completely gloss over them. So I had to confess, when I saw this image used as the header for my talk, I'd completely forgotten about this event. The WOW signal was a strong, what is that, electromagnetic signal received on August 15th, 1977 at the Big Ear radio telescope, then used for extraterrestrial intelligence, looking for SETI essentially. The signal appeared to come from the direction of the constellation Sagittarius and bore all the hallmarks of an extraterrestrial origin. It was detected once and has not been detected since. At the former site of the Big Ear telescope is this historical marker. At the heart of the Eagle Nebula, M16, the Pillars of Creation. The original historic image on the left was taken in 1995. It's my mother-in-law's favorite. In 2014, Hubble re-imaged the pillars in higher resolution. The image on the right is the pillars seen in infrared light. The number of stars hiding in IR is simply astounding. So, speaking, well, wait, where did that go? There we go. Okay. The human eye is only able to see light in a very narrow band in the electromagnetic spectrum. And it's actually a pretty awful instrument for observing the cosmos. There's a whole lot more out there than meets the eye. And something that many of us can appreciate on a deeply personal level is how expensive instruments to see in that narrow band in the electromagnetic spectrum can be. Like $1,400 for an eyepiece just gives me the vapors. So Saturn, what can you say about Saturn? What can you say about the most look at me object in the solar system? Well, apparently a lot, like whole presentations worth. Practically everyone who's had members of the public look through their telescope, especially first timers, has heard them exclaim, wow. And when I was at a science fiction convention, a young woman jerked back from my scope, looking at Saturn and said, oh my God, looked again, and then ran back into the hotel running, you got to see Saturn in this guy's telescope. Well, I guess it had an effect on her. So Saturn's beautiful rings are made up of countless trillions of pieces of rock and ice. But that beauty is born in an incredible act of violence. An icy moon got it just a bit too close to Saturn, and Saturn's tidal forces tore it apart. Imagine standing on that moon as this event happens. In 1992, comet Shoemaker-Levy 9 was torn apart by gravitational forces from Jupiter and stretched out into a string of smaller bodies. These pieces collided with Jupiter in 1994. The impacts created the most titanic explosions witnessed in the solar system, aside from the sun. The impact scars could be seen for months, and it was an eye-opening big wow for planetary defense. Asteroids and comets still do hit the planet to Earth, and they can hit hard. I can't remember the first time I saw the moon through a telescope. It must have been 8-year-old, who knows. Those of us who who have set up telescopes and shown the moon to the public, you've always gotten wows every single time. I was at a science fiction convention with my telescope, and it was a prom night, and fancy dressed young people were pouring into the hotel, and I was calling them over to look at the moon. I was zoomed in on some craters, and I had one young lady say, "Wow, how'd those get theirs?" And about a million thoughts went through my mind. I knew she wasn't asking me for a dissertation on asteroids and asteroid impacts, crater and ray morphology, space weather, and geologic timescale. So I said, asteroid impacts. Now that was enough. So what's really wow-worthy is how impact craters show up everywhere in the solar system we care to look. The Lunar Reconnaissance Orbiter and the Mars Reconnaissance Orbiter have imaged fresh impact craters too. My college roommate, when I asked him, what makes you say wow, he said seeing the Jupiter-Saturn conjunction last December during the day, and I've seen Jupiter during the day in a telescope too. That is pretty cool. Brother Guy said seeing the Carina Nebula in the southern hemisphere is simply amazing. Inside, at the heart of the Carina Nebula, is the binary star or more, Eta Carina, which had an outburst in 1843, which created this ever-expanding homunculus nebula. I'm pretty sure I said, wow, the first time I saw that thing. When Stuff Moves was a suggestion by Dr. Brian Odom. He gave a presentation at a science fiction convention I was at where he used his remote-controlled telescope to track a satellite. That was pretty darn cool. And apparently Doug Bach likes things that move too. I shamelessly stole this comet image from his Twitter account. And speaking of comets, it's surprising how many items fitted under the stuff that moves category. Here's Comet Neowise from, was it last year? I know numerous people that got shots of this thing. Meteor showers. Meteors, always a crowd pleaser. They can be fleeting or tumble across the sky from horizon to horizon. I am impatiently waiting for a repeat of the 1833 Leonids meteor storm. I've just barely missed my fair share of meteors too, but when I hear someone say, "Did you see that one?" I'm glad somebody saw it. Bolides, or when meteors explode. This can be an exciting crowd pleaser as they flash across the sky, or they can be big ones, like the Chelyabinsk event in 2013 that blew out windows and injured people. Or they can be really big ones in level forest. Crowds will want to be 50 miles or more away from them and wear eye and ear protection for these. Shadow transits of Jupiter's moon. I've been lucky enough to see a couple of these at Stargate Observatory, and it's really cool if you can see the moon causing the shadow against Jupiter's disk. These transits happen frequently enough that it's not really difficult to catch one. And when I think of transits, one of my first thought was seeing the International Space Station go in front of the sun. So I went and looked for that image, and I found this one with the International Space Station and the Mercury transit. Talk about timing. What a wow-worthy shot that is. TNO Arikoth briefly blocked the light from a star during an occultation in July of 2017. 24 telescopes in southern Argentina captured this event, and they revealed Arikoth's possible bilobate shape. The New Horizons flyby in 2019 showed that results from the occultation precisely fit the observed size and shape. That is really cool. Occultations are also used when an asteroid occulted a star, and it was discovered there was a dimming before and after. This sucker has rings, so an asteroid has rings, and it was discovered by occulting a star. So sunspots, you can watch sunspots change shape and morph over the course of a couple of days and weeks on the sun. You can watch prominences change shape over the course of a couple hours, and they can be quite astounding. Solar flares release enormous amounts of energy into space, and if you're really lucky, you might see one on the sun. But they're kind of difficult. I was at a convention, and I actually saw something was very similar to how Carrington described his historic flare of 1859 with a couple of bean-shaped things getting really bright. I saw that. That was cool. If any energy released from the sun interacts with the Earth's magnetic field, it can create auroras. Auroras can range from meh to wow to, oh my God, the whole sky's on fire and moving. I think I should be frightened now. And I've seen all of them. Total solar eclipse. I've heard many WASP members explain how wow-worthy these are. I've yet to see one. I'm waiting for 2024. I will. I have seen these guys annual solar eclipse and countless numbers of lunar eclipses. I've seen a bunch of these. The last one before COVID, I had so many neighbors looking through my telescope, I couldn't even get any photographs of it. So the speed of light is a universal physical constant. And when light is emitted from a source, it takes time for that light to reach our eyes. If that source is very far away, it can take light a very long time to reach us. So when you look out into the night sky, you're looking back in time. I've heard wow several times describing this. Fortunately, light having a speed limit prevents us from seeing everything from happening all at once. So that's good. Size and distance. You could do an entire presentation on this topic alone. In fact, I know people who have. The Hitchhiker's Guide to the Galaxy by Douglas Adams said it very well, and I'll try to do it like they did in the original radio play. Space is big, really big. You wouldn't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down to the chemist, but that's just peanuts to space. And how true is that? So the short video, Powers of 10 from 1977, was my first introduction to the mind-bending concept of size and distance. And it still holds up today, although the music's a little funky. So I hear this constantly when talking about size and space. It, invariably, it makes me feel so small. Well, that all depends on your point of view. I mean, to the bacteria in your gut, you are unimaginably huge. And besides, if you were much bigger, you'd be one of these. So you're pretty much sized just right in the powers of 10 scale. So speaking of stars, compared to some stars, our sun, that little dot over there on the left, is tiny. And yet our sun is bigger than 80% of stars. Class M red dwarfs make up the vast majority of stars in the heaven, and they're dim. They're only about 8% the luminosity of our sun. So Proxima Centauri, the closest star to us, is a red dwarf, can't be seen with the unaided eye. And the smallest red dwarfs have lifespans in the trillions of years compared to our sun's 10 billion or so. Some red dwarfs flare quite spectacularly, and in May 1, 2019, Proxima Centauri increased in brightness 14,000 times in ultraviolet. Proxima Centauri 2 has 2 confirmed exoplanets orbiting it, and a flare of that magnitude would very likely be a bad thing for any atmospheres and biospheres on those worlds. So exoplanets, planets orbiting other stars, are no longer a thing of science fiction. As of this morning, there are 4,455 exoplanets have been confirmed. And the growth rate of discovery of exoplanets is just astounding. It's estimated there are hundreds of billions to a trillion exoplanets in our Milky Way alone, all vastly unimaginably far away. So getting back to stars, they have some very interesting life cycles. They condense out of gas and dust in the interstellar medium, and at the end of the life, they release gas and dust back into the interstellar medium, which new generations of stars form. So stars 8 times or more massive than our sun can end their lives in a supernova explosion, becoming as bright or brighter than that star's home galaxy. Supernovas are something life-bearing planets do not want to happen close. Right there. Okay. Supernovas. Okay. The lifespan of massive stars is fleeting compared to our sun. Stars explode at the rate of about 2 per century in a galaxy like ours. That's over 4 million supernova during the 230 million years our sun takes to do its weird wavy orbit around the galaxy. When viewed at geologic time scales, our galaxy would twinkle with supernova explosions. Now, the estimate of the number of black holes in our galaxy is 10 million to a billion resulting from that. So neutron stars are a result of a supernova. They can be city-sized, super dense, massive magnetic fields, huge gravity, fast spinning. Some of these fast spinners have relativistic jets that act like cosmic lighthouses, flashing tens to hundreds of times a second in the X-ray and gamma ray range. Black holes, another possible result, supernova explosions. And then you have the really big black holes, like the center of our galaxy, 4.3 million solar masses. So stellar nucleosynthesis is the creation of chemical elements by the nuclear fusion reactions within stars. It's been ongoing since the Big Bang. Light emitted from hot elements like those in stars, or light absorbed by cold gases like the clouds and gas and dust, have a fingerprint in the spectrum of light. With this discovery, spectroscopy was born, a branch of science concerned with the investigation and measurement of spectra produced when matter interacts with electromagnetic radiation. It's a fundamental tool used in physics, chemistry, astronomy, allowing the composition and physical and electronic structure of matter to be investigated at the atomic macro scale and over interstellar distances. If that isn't wow worthy, I don't know what is. Using spectroscopy, a whole bunch of molecules have been discovered floating in the interstellar medium. Some very interesting molecules, including organic and prebiotic molecules. What's interesting is most of the elements and chemicals that make up life and life uses are common throughout the universe. So when I'm asked, do you think there's life in the universe? I say, well, where do you think you are? So, and Brother Guy said, if it has happened, it can happen. And we've got a lot of life here. So, yeah. So, Chuck Dazella gave a presentation at DETCON describing the chemistry of life and how we are star stuff. And one of his slides shows the similarity between hemoglobin and chlorophyll. And this just went beyond a wow moment to a completely blowing me away moment. Cosmic rays, high energy particles that move through space at nearly the speed of light. They reach Earth at energies of 10 to the 8th to 10 to the 20 electron volts. Higher energy one come from supernova. When they hit the atmosphere, they create a shower of secondary particles. Their effects are small but constant in every place on the planet where life could evolve. Astronauts have seen them flashing their eyeballs too, which is kind of ew. Dr. Partin has given an entire presentation on these. Relativity. I would say, wrong one. Neutrinos, created in the fusion process in the store of cars. Neutrinos are elementary particles that are pouring out of the sun in all directions. These weird particles interact very weakly with normal matter, and every second, about 65 billion solar neutrinos pass through every square centimeter of your body. Now take that square centimeter and make that into a sphere around the sun. Adds a lot of neutrinos. General relativity, gravity is not a force between masses. Instead, it's an effect of the warping of space and time in the presence of mass. Gravity waves created by the mergers of black holes are ripples in that fabric of space-time, and we can detect those. It's crazy. Black holes and neutron stars merge, so do galaxies. We see galaxy interactions and mergers happening all the time. They can be energetic and spectacular. This image shows the mice. Now imagine, if you will, you're in a world orbiting a star here. What would your night sky look like? That would be, you'd have tubes of light in two different directions in two galactic cores. It would be amazing. So working on my weekly posts, I saw this one from Mars Reconnaissance Orbiter image of Mars, and I just constantly seeing just beautiful pictures of Mars that I say wow about all the time, and they also do 3D images sometimes. And then there's this weird thing that Curiosity found on Mars. I saw this and I said, that's fake, and I went and looked, no, that's real, so rar, that's kind of weird. And drawing and painting astronomical things. Galileo sketched the moons. I see astronomical artwork plastered all over social media today. The Astronomical League has an active sketching program. Connie has had her students sketch the moon. So drawing can be educational and has historic significance. So astronomy is a rabbit hole. The deeper you delve into astronomy, the deeper you delve into multiple branches of science. And I've had over 80 slides here, and I'm sure I have missed things that have made members of the audience say, wow. But that perfectly illustrates my point. There's a lot of things in astronomy that make you say, wow. And hopefully I've given our membership a boatload of ideas for presentation topics of their own, hint, hint. So I'm really looking forward to the day when people again pull away from my telescope with a startled look on their face saying, wow. Thanks, everyone, and clear skies.
Thank you, Bob, for that wide-ranging display of enthusiasm, and I like the personal touches from some of our colleagues. So, any questions for Bob before we take a 20-minute break?
Yeah, I have one.
Excellent.
Bob, I have been looking forward to this talk
Oh, no.
since I saw it announced, and I have to say that I was not disappointed. I really, really loved it. As I was listening to the things, and it brought back memories of the wow moments I have had. And you may think that those wow moments all involve discoveries of comets. And certainly those were very special moments for me. But I have a wow moment that I would like to share. And that is the first time I ever looked through a telescope. It was September the 1st, 1960. I had the telescope pointed at Jupiter, and Galileo could have felt no greater thrill than I did that night when I showed my parents the moons of Jupiter. And it was absolutely riveting for me to see these things happening in the sky right over our house was something I will never forget. And every time I inaugurate a new telescope, the first light ceremony for each new scope, except for this one, has been to look at Jupiter. And I really, really recommend that. So that's my wow moment. September the 1st, 1960. I will never forget it.
I was 4 months old.
Very much into
Sure, it was
astronomy.
born. So David, what was the first light moment for the telescope, for the Minerva telescope next to you?
Minerva was the moon. I think Jupiter wasn't in the sky that time, and I used the moon for Minerva. But I've looked at Jupiter with this telescope many, many times, especially, and I guess that might have been a wow moment in itself, using this telescope to look at Jupiter in August of 1994, and I could see with this telescope impact spots. Well, in this telescope, there's a law, the Senate passed a law that you're not allowed to see impact spots using a wide field telescope, but I did, and I paid the fine. And this
It was
is
worth it.
it certainly was worth it.
Great presentation, Bob. Fantastic.
Thank you. Most of the time was spent finding pictures for it or creating pictures for it.
Very exciting. Very exciting.
Well, like I said, I'm sure I left stuff out. Well, from the 10 slides I have hidden that I didn't finish, I know I left stuff out.
There's no question about that.
No, there's only one thing that I think my wow moment that you didn't cover. You covered every last wow moment I've seen or observed or watched. I've seen the tears too, just as someone's had such a wonderful experience looking at the night sky through telescopes. But my wow moment is going to a site dark enough to where you begin to see color in the Milky Way, as well as structure and all of the other, basically all of the other pieces of the Milky Way, and to see it stretch from from the southeast where it rises to the northeast where Cassiopeia is. That was my wow moment, and that was off of a highway 123 heading to Paradise, Michigan, and it was clear 3 in the morning, and I knew that the Milky Way was rising. Got out, forfeited my chance to catch it over to Quamanon Falls because it was a very wide area, and looked up and saw it go from horizon, from one side to the next, and stood there for maybe 5 minutes before I finally got my gear out. So that about the only thing, seeing the Milky Way in that much detail with the naked eye for the first time was a huge wow moment for me.
I had a weird wow moment. My first wow moment was actually looking at Mizar and Alcor through a telescope. I found that to be so unbelievably compelling. The other things are all wow moments, of course, but first time you take a look at a double star and you say, really, how'd that happen? You know.
Very nice. Yeah, and the chat is filling up. If you haven't been keeping an eye on the chat, we've got everybody sharing other things ranging from comets to launches to the double star Albireo. first observations. So keep that rolling. Feel free to turn your camera off and grab a snack or a drink. We will reconvene at 9 p.m. for the feature presentation. Feel free to throw up any pictures you've got too.
Oh, I got one from last night's run.
Yes, please.
Yeah, finally, after a month of crummy weather, I got out last night. Last time I was out was July 1st, so last night's August 1st. It's been a whole month. So let me see here. I took, with my new camera, decided to go after the bubble. So I'll share that. This is my shot of the bubble from last night. For about 4 hours and 45 minutes of data.
Dang, that is some detail, Doug.
That's some good data. And knowing your process, you know it's really good data because you run it through. Your process is fairly quick, but it's pretty good. So yeah, that's excellent.
That's with the new ASI 2600 camera that I picked up last month. This is only the second night out with it. So, yep, came out pretty good. I still have some tweaking to do on the optics, but I was kind of pleased with the results. And then, of course, I have that piggyback scope as well, or camera. And this was the area, and I want to do a little more work with this one. This one didn't turn out the way I had hoped, but so this was the same area shooting at the bubble with the 300 millimeter and the 071 camera. But here's a plate
And
saw
that's
of the area.
And that's the Nova that's still in the sky.
Yeah.
Next to M52. Yeah. Yeah, the very few times that I've shot and had a clear sky, I haven't necessarily looked to see if it's still visible there.
Yeah, this is last night as well. This is 4 hours of data at unity gain. So not a lot of depth in the target. So I'm going to probably bump this guy back up to 240 for a gain and see how that works out. But it was that's the raw, or that's the
Yeah, I don't know how much in the way of galaxies are in that actual region, though. I don't know if it's
no, it's mostly should be a lot of nebulosity is what should be there. So there's I also got I had a lot of weird things going on last night. I got these stripes in it now. So I was out there 2 hours messing with the optics, getting alignments and stuff like that before I even got started. I got started about midnight, and it ran until 5 this morning. So anyhow, that's what I got for last night's run. And I'll be doing some more work tonight. It's a little more milky tonight out there, but gotta use what I can. And then I think I'm going to head to Boone either tomorrow or Wednesday, but probably tomorrow. So that's all I got.
yeah, I showed some images earlier. I was near Traverse City and hoping that I'd be in a pretty good area. I saw the blue skies during the day. I actually had a wedding job that I was doing, but I brought some lenses in my tracker to be able to do some wide angle astro. And I looked up and saw that it was very hazy and things were blocked, and it didn't seem to be due to any nearby light pollution or anything else. So I was thwarted again. It must have been good last night for you, Doug, but up in Aden, Michigan, near Traverse City, we had smoke show up. So I must have been right in the smoke line.
There's smoke line that went across Traverse City around to the west down Lake Michigan and underneath us. So we had relatively clear weather here. And
Yeah.
the smoke's coming back tomorrow or the next day. So I'm not anticipating, and then clouds. I'm not anticipating any good weather necessarily over the next week and a half, but I'm going to go up
Yeah.
anyways.
Well,
All right.
there's
Tomorrow should be pretty good.
Pardon me?
no.
Today and tomorrow, at least
Yeah.
tonight, I think.
Yeah. Tonight should be good. I'm going to go open up right now, so I'll be back.
All right.
I've
Yeah,
been imaging the Eastern Veil. I have 10 hours in. I haven't really looked at the data, but just from my initial, I haven't processed anything. Just looking at the initial single shots, they look pretty clean. So I'm tempted really to take apart my telescope and put on the Schmidt-Cassegrain and take a look at. I have not looked at any of the planets this year. I have such a narrow window between trees. It's like, well, Saturn's up at 2 a.m. Like, well, I'm not going to be up at 2 a.m.
So it's getting closer. Yeah, you haven't seen the planets because they rise later and later this year.
I see them when I'm driving home from work or something.
Yeah.
Like, oh,
up there.
Driving home from something is like, oh, well, there's Saturn, there's Jupiter, or even there's Venus. It's like, well, I can't see any of them from my spot. I can almost never see Venus from where my telescope is set just because of trees and houses. It's too close to the sun.
We're almost in planet time mode.
Yeah, I know.
And for all the Milky Way shooters, we're gonna get a receding Milky Way in about in a month. The Milky Way is gonna be standing straight up, and it's gonna be going down at sunset. So we're gonna lose the core.
My wife's cousin's kids. I told her cousin that I was like, hey, the planets are coming up. Come on over at some point when it's not super late. Maybe end of August or September. It'll be darker as well. It's like, hey, come on over to my house and I'll do a mini outreach and have the kids look at Saturn and Jupiter. My next door neighbor kid, he's 10 years old. He's never looked at anything like that. So it's just, I just have so much obstruction for anything low in the horizon. I just have a narrow window. In the winter, it's a little bit better because there's no leaves. But yeah.
I think I'm gonna take Dr. Dale Partin's lead. Go grab me something to eat. I don't know what you're eating, and it still looks good, Dale. So I'm going off camera.
I got Frankenmuth sauerbraten in the microwave right now.
Yeah, it's time to nibble before this next presentation here. So I'll go do that.
Get leftovers.
But yeah, it's been a tough summer to do any imaging or anything with all the smoke going on.
I got my system so set up for automation that it's like 10 minutes and I can set it up for all night as long as it's going to be clear. I come
right. So yeah, at least you have that.
It's off and running.
3 hours of setup, and if I get there and it's smoked over, it's a wasted night for me.
Yeah, I know.
It's another fun road trip is what it turns in, or another cloudy image is what I end up producing.
Kind of itching for a road trip, but just timing. Time.
Yep.
Wine, bread, and cheese.
That sounds perfect. All right, I'll be back.
Shop in Frankenmuth too, or actually, I should say Pinconning. So, yeah.
Does somebody know a good website for knowing when the sky will be smoky?
Check out earth.nullschool.net.
Earth.
Null, N-U-L-L, or I'll put it in the chat. You have to go, when you get there, you're going to go into the mode under particulates, and they have different particulate sizes. And then you can use the arrows to go forward to see what the forecast is. And they also have jet stream forecasts or wind at any number of heights. You can scroll through and do the same. So you can look at the current conditions, and then you can look at the forecast. I think it goes up to maybe 3 or 4 days ahead into the future.
Okay, thank you.
Yep.
How long before we start again?
9 o'clock.
Oh, like 2 minutes. Okay, then I won't be showing this video.
All right, everybody, it's the top of the hour. Let's come on back. See if your faces have popped in since then.
Can you hear me, Diane?
I can, Jim.
I don't know whether I'm in or out. There's
You're in.
been
We can hear. We can see you.
bunch of complications trying to get into the meeting. I don't know why, what has happened that we've changed protocols.
Well, your connection is also really bad. Your audio is cutting out.
Okay, never mind.
Anyway. All right. Well, thank you very much. And I have the honor tonight of getting a bit out of turn because I am the one introducing the speaker tonight. Usually that is the job of the first vice president. However, our sitting first vice president, Dr. Dale Partin, is our featured speaker tonight. And so I'm here to say a few words about him. Of course, Dale is a familiar face, being a past and current first vice president of the club, as well as serving in recent years as a secretary and a treasurer, and in other roles before I even joined the club. Dale was one of the people who made an immediate impression upon me upon entering the club. There were several old hands who were extremely welcoming towards me and Jonathan when we showed up, many of whom are no longer with us, like Bob Watt and Larry Kalinowski, who were absolutely welcoming to newcomers. But Dale and Jonathan and I were among the few participants at a stormy, chilly Stargate open house. And it was a time for hanging out under the eaves of the dome and engaging in conversation. And those conversations were remarkably vulnerable and memorable and crafted the kind of personal connection that sustains an organization like this, wherein people that from different walks of life, different philosophies, can truly become friends and respect one another and engage in the hard and oft tiresome work of keeping a 501c3 nonprofit afloat, as well as being able to kick back and have fun and talk about the possibility of life in the universe, or, you know, what kind of building we should have at Stargate next time around. So I would like to cede the floor to our presenter, Dr. Dale Partin, your program chair.
Thank you, Diane. I actually remember that very night sitting on the north side of Stargate Observatory, talking with you and Jonathan. Wow. It's been a long time. Okay. Let me see if I can get my PowerPoint to work. Can you see it?
Yes, though it's not
Okay.
full screen yet.
Let me see what I can do.
I think if you hit play or whatever the equivalent thereof is for PowerPoint. Yeah.
Is it filling the screen for you?
No. There we go. Yep. Now we're in.
Okay.
All good.
Well, it had been a while since I've given a presentation here, and I considered various possibilities. I even considered an update on searching for extraterrestrial intelligence, because there's been some new things there. People, instead of just looking for radio waves, radio signals, they're looking for laser signals and things like that. But they haven't found anything. So I decided to give to explore the topic of and give a presentation on exploring the Galilean moons. It's not that I know or knew everything about them, but it gives you a reason to look into that topic. And so I would encourage those of you who just have a germ of an idea for giving a presentation on something, get busy and dig into the topic, and you will become knowledgeable about it and can give a presentation. So I think a lot of you know that I teach introductory astronomy classes at Macomb Community College. I'm also a student at Oakland University, where I take classes on every topic you can imagine, just for the fun of it. I like to learn new things. So the telescope was invented somewhere around 1609, and Galileo heard about it and started making his own telescopes. And when he finally made one that had about 20 times magnification, which meant it was probably by far the best telescope in the entire world at the time, even though the optics were terrible. The field of view was like looking at the sky through a straw. The field of view was so small. Nevertheless, with that telescope, he changed our understanding of the entire universe. One of the ways he did that was when he looked at Jupiter. At the bottom of the slide, you see two pictures of Jupiter and its four largest moons, Io, Europa, Ganymede, and Callisto. Notice how they kind of line up. That's because we're seeing they have nearly circular orbits, but we usually see them pretty much edge on. Sometimes there's a little bit of tilt to the plane of their orbit from our line of sight, but generally they're pretty much in a straight line, lined up on Jupiter from our perspective. And these two pictures, one above the other, were taken just 24 hours apart. And you can see that those moons really move. Callisto is the moon that goes the farthest from Jupiter, so it moves a lot more slowly. But here you see Io and Europa went all the way to the other side of Jupiter. This was pretty astounding back in 1610, because a lot of people worldwide still thought that the sun, well, the Earth was the center of the universe, and the sun and everything went around the Earth. And here were some moons going around something other than the Earth, going around Jupiter. So this was a major discovery, and it ultimately gave support to a heliocentric model of the solar system, meaning all the planets rotate around the sun, and some of the planets have moons that orbit the planets. I think this is kind of fascinating. It's a picture of his notebook from the first time that he saw Jupiter through his telescope. And it's kind of hard to read, but he's just sketching what he saw. Little bright stars, he thought they initially were, but he noticed they were in a line with Jupiter, and then, you know, they moved around. Here is an English translation of those notes. You can see that on the 7th of January, he saw 3 of the moons in Jupiter. On the 8th, the 3 moons, 3 little stars he initially thought they were now all on one side of Jupiter. On the 9th of January, he had cloudy weather. And then on the 10th and 11th and so forth, you can see he's tracking the motions of these moons, and he's getting excited. 2 months later, he published his observations in something in Italian called Sidereus Nuncius, which means starry messenger. I should disclose and publish to the world the occasion of discovering and observing 4 planets, he called them, never seen from the beginning of the world up to our own times. Can you imagine discovering 4 planet-like things that no one had ever seen? Discovering them, their positions, and the observations made during the last 2 months about their movements and their changes of magnitude. And I summon all astronomers to apply themselves to examine and determine their periodic times, which has not been permitted me to achieve up to this day. So he goes on to tell the story. And I'll just take you to the end of it. I therefore concluded and decided unhesitatingly that there are 3 stars, he's calling them here, in the heavens moving about Jupiter as Venus and Mercury around the sun, which he had also seen, which was at length established as clear as daylight by numerous other subsequent observations. These observations also established that there are not only 3, but 4 bodies performing their revolutions around Jupiter. So that was his story. It was an exciting, world-changing kind of story. The little picture I put here on the slide of Jupiter and its moons is probably way more clear than what he could see with his telescope. These days, we know that Jupiter, last I heard, had 79 moons, not just 4. Most of them are quite small. As we will see, these 4 moons are comparable to the planet Mercury or to our moon in size. A lot of the moons of Jupiter are 1 to 10 miles in diameter, pretty small. I got my first real telescope in 1997, and being kind of a physics-oriented kind of person, I needed a little project to do. So I decided to figure out the periods of the moons of Jupiter. Let me ask, can anybody unmute and tell me, can you see my cursor?
Yes.
Yep.
Yes.
Okay, good. So in this diagram, the horizontal axis is time measured in hours. And this represents roughly 1 month of time. The vertical axis is distance, angular distance from Jupiter, from the center of Jupiter. Here's the center of Jupiter, this dashed blue line. And so each moon, for example, these 4 moons are either on one side of Jupiter or the other side of Jupiter. And I measured how far each of those moons was from the center of Jupiter a dozen or so times during that month using this special eyepiece that I bought. Actually, the one I have is from Celestron, and I don't think they sell such a thing anymore, but Meade does. It has a reticle inside the eyepiece so you can measure things. And this is something with a battery and a little red light emitting diode in it to illuminate the scale if the sky is so dark that you can't see the scale. So, for example, I would put Jupiter, I would center Jupiter on this end of the scale and measure how many of these divisions it was. I'm sorry, I have a bit of a cough tonight, so if you can hear me with a cough drop in my mouth, I apologize. So I could measure how many radical divisions it was from Jupiter to the moons on one side of Jupiter, and then I would move Jupiter up to this end of the scale and measure moons on the other side. And there's a way of calibrating this scale. If you put Jupiter down here, for example, slightly off scale, and turn off your telescope drive and get ready with a stopwatch, and as Jupiter drifts, you click the stopwatch when it hits this end of the scale, and as it drifts with the rotation of the Earth to the other end, and you stop the stopwatch there, you can measure that time to easily 1/10 of a second, do it repeatedly. And by doing some calculations on how fast the Earth rotates and what the declination of Jupiter was at the time, you can calculate what angle corresponds to each of these little divisions. Here I show the calibration. 10 arc minutes is here. So, excuse me. I started taking data, and at first, from one night to the next, the moons are all jumbled up, and you don't know, at least I didn't know, which moon was which from one night to the next. It's confusing. And my eye is not that sensitive to small brightness differences between, say, Europa and Ganymede. So I couldn't do that. But after several nights, I just greatly expanded this first part of the scale and just tried hand drawing sinusoidal waves until I figured out which moon was which. And then, for example, here's the motion of Callisto, the moon that goes the farthest from Jupiter and therefore it takes the longest time to go around Jupiter. So I could figure out its period from the period, on a computer, I played with the period of the motion, the amplitude, and the phase. This curve gets moved back and you can move it back and forth. So for each of the 4 moons, Callisto, Ganymede, Europa, and Io, I found the period of the motion. Here's my data. I gave a talk on this back in 1997 to the Warren Astronomical Society. I still remember doing it. So for each of these moons, I call them J1, 2, 3, and 4. Here's the number of days I measured. Here's professional data for comparison. The professional data is known to lots of significant digits. I just rounded it off to compare. Here's my error compared to the professional data. It gets bigger, the error, the slower the motion is, because I only measured 2 periods for this moon, Callisto, 1, 2, whereas for Io, goes the red curve, it goes up and down so quickly that you can get a much more accurate measurement of it. Then I was amazed when I tried taking the ratios of these numbers. If I took the period of Europa and divided it by the period of Io, I got almost exactly 2.0, which told me those 2 moons are in resonance with each other. I did the same thing with the period of Ganymede versus Europa. I again got a period, a ratio of 2. So they're in resonance. And then Callisto and Ganymede, I got 2.33. I don't know whether that means they're not in resonance or whether it's a more complicated kind of resonance. There are such complicated resonances in the solar system. For example, between Jupiter and asteroids in the asteroid belt, you find such resonances. So that was the study I did. It was a lot of fun. John Dumar in the Warren Club did a much more accurate study, taking pictures with a fairly high resolution camera of the moon so you could more accurately measure the positions. And gave a presentation a while back. And it's also known, by the way, that all 4 moons orbit synchronously around Jupiter, by which I mean the same side of each of those moons always faces Jupiter, just like our moon always has the same side facing the Earth. So that was kind of fun. That's something I presented in a little bit of length because it's nice for amateur astronomers. You can do this kind of stuff, or at least you've all seen Jupiter and its moons through a telescope. You can at least relate to it. But there came the time after the early space program in the late 50s and 1960s when people were putting up spacecraft into low Earth orbit and started talking about going to the moon. We sent the Mariner spacecraft to Venus and Mars. All of that was very early, groundbreaking stuff, but no one had sent a spacecraft out to Jupiter or anything beyond it, at least not to Jupiter and Saturn and so forth. So there was a man named Gary Flandreau, who was an engineer at Jet Propulsion Labs, who in 1964 noticed that if you looked at where Jupiter, Saturn, Uranus, Neptune, and Pluto, then a planet, where those 5 planets were and how they were moving, he said, in a few years, it'll be an ideal time to send 1 or more spacecraft to visit all of them. So he called it the Grand Tour. So this lit up some people at NASA. And the first thing they did was build 2 spacecraft, Pioneer 10 and Pioneer 11. They were sent to Jupiter to explore issues that might be encountered later by the Grand Tour spacecraft that they would subsequently send. For example, if you look at the solar system, Let me move this out of the way if I can. Come on, there it is. If you look at a simple model of the solar system, there's an asteroid belt mostly between Mars and Jupiter. Nobody knew how many asteroids were in the belt, how many, fist-sized asteroids there were, or even grain of sand-sized asteroids. Nobody knew whether a spacecraft could get through the asteroid belt without hitting something and getting destroyed. So these were relatively inexpensive spacecraft. They were sent to Jupiter to explore issues. In particular, nobody knew if the asteroid belt would look something like this, right? You better not try to go through that if that's what was out there. And an impact when you're traveling at really high speed, like 50,000 miles per hour, you don't have to hit something very big before it becomes devastating to a spacecraft. Also, they kind of knew that Jupiter, there were indications that it had a substantial magnetic field trapping a lot of radiation around it. Nobody knew how bad that would be and how difficult it would be for a spacecraft to survive going through that. And we didn't even super accurately know the mass of Jupiter and its moons, which would be important for navigation, because as you approach Jupiter, its gravity would change the orbit of the path of a spacecraft, especially if you wanted to use the gravity of Jupiter to slingshot you toward Saturn. You had to know things pretty accurately, and they didn't. Another issue was how would you power, how would you get electrical power for these spacecraft? When you're sending a spacecraft to Mars, the intensity of sunlight is roughly half of what it is here on Earth because you're moving farther from the sun. Jupiter is 5 times farther from the sun than the Earth is, and so that means sunlight is 25 times dimmer. It becomes pretty tough to operate a spacecraft out there using solar cells, especially because the solar cells back then were not very efficient. And then if you want your spacecraft to go out to Saturn, now you're talking about 100 times lower light intensity than you have here on Earth. It's just not going to work. So they used nuclear electric power generators rather than solar cells on these missions. Not only is sunlight less intense to power solar cells, but radiation degrades solar cells. So these radioisotope thermoelectric generators, these nuclear power generators, work pretty well. So these missions were launched in the early 70s. Pioneer 10 got to Jupiter in 74 and then went on to Saturn. Well, it was supposed to go on to Saturn and Titan. They did get some impacts, small ones, fortunately, traversing the asteroid belt. Interestingly, only 6 of the spacecraft's 11 instruments were still working after the Jupiter flyby. The spacecraft was pretty useless at that point. They went, and here's some pictures that the spacecraft took. They didn't get terribly close to Jupiter. It was 81,000 miles at its closest approach. Look at all these lines. That's because they used a standard TV camera back of that era, which are not very high. Were not very high resolution, not very sensitive to low light levels. Not so great, but that's what they had for this mission. They also sampled the radiation around Jupiter, and it was high, but they went through past Jupiter pretty fast. So that's, and they did not go close to any of the Galilean moons, so they got no clear images of them. The camera they were using failed before any image of Io was even taken. And the spacecraft did not later pass near Saturn or any other outer planet. They, having seen Pioneer go past Jupiter and kind of survive, they steered Pioneer 11 a little closer to Jupiter and in an orbit that would then swing it over towards Saturn later. Pioneer 11 did not have any impacts going through the asteroid belt, and it came a lot closer to Jupiter. Here's the best picture they got. Here are the best pictures they got of the 4 Galilean moons. Not terribly illuminating. Typically, the closest they got to any of the moons was 300,000 miles, which is roughly comparable with the distance that our moon is to the Earth. So you might think, gee, you can see the moon with your bare eye about this well. Why are these pictures so blurry? Again, the camera was not very good, and the light level was very low. That's the best excuse I can give for it. I'm not going to be talking about things other than the Galilean moons, but I can't resist saying Pioneer 11 did pass by Saturn. Here's one of these are the better images they got of Saturn from that spacecraft. And here's the best image they got of Titan, where they observed a thick, opaque atmosphere, but their measurements said it was extremely cold for life. This is basically the temperature of liquid nitrogen. So that sets a stage for 2 better spacecraft, Voyager 1 and Voyager 2, for the Grand Tour. This diagram is kind of a schematic of the solar system showing what they were going to do with these 2 spacecraft. Basically, initially they considered sending 4 spacecraft just to make sure they got everything they want to get and have multiple passes and so forth, but that cost too much. So then they changed their story. They were only going to send 2 spacecraft and visit Jupiter, Saturn, and Titan, the biggest moon of Saturn, to cut costs. And behind the scenes, they figured at least one of these spacecraft, if the first one to go past Saturn got a good picture of Titan, then they would adjust the path of the second one so that when it went past Saturn, its path would be bent by Saturn's gravity to go to Uranus and then to Neptune. One of the spacecraft, the first one, Voyager 1, not only went to Saturn, but went close to its big moon Titan. And unfortunately, as they well knew it would, getting close to Titan meant that the path of Voyager 1 was tipped out of the plane of the solar system. So if you just look at the plane of the solar system, they could have steered it to Pluto, but it wasn't in the plane of this diagram. The path had been bent by Titan well out of the plane of the solar system. They did not have enough fuel to redirect it toward Pluto. As you likely know, both Voyager 1 and Voyager 2 are still alive, traveling into the, well, they're well beyond, obviously, Pluto and Neptune. They're pretty far out there, but in a sense, they haven't even hardly gotten anywhere yet if you compare their current positions to the Oort cloud. They'll never get that far before their nuclear generators, electric generators, run out of power. And these spacecraft weighed 3 times as much as the Pioneer spacecraft, so they had more radiation protection built in and better instruments. So these are some of the better pictures that they got of the Galilean moons. Io was the biggest surprise. They didn't know it until they were already well past Io and Jupiter on their way to Saturn. But later, when they were studying images of Io, somebody was playing with brightness and contrast, and all of a sudden they noticed, it was a lady scientist, I don't remember her name, she noticed something sticking up above the surface here. And when they studied this, they concluded, and from the surface, that this was an amazing thing out here by Jupiter, far from the sun, where everybody thought everything would be really cold. There were hundreds of active volcanoes heated by tidal friction from the fact that Io's orbit is slightly elliptical around Jupiter. So sometimes it's closer, sometimes farther from Jupiter. And Jupiter's gravity is so strong that when the distance to Jupiter changes a little, it squeezes or compresses the moon, generating heat from friction, internal friction. They did not yet know it, but later spacecraft that I'll be talking about also found that there's a strong plasma current of ions flowing between Io and Jupiter, which also heats Jupiter. In these spacecraft views, Voyager 1 got the best view. These volcanic plumes, which are mostly sulfur and sulfur dioxide, extended up about 100 miles above the surface of Io. Europa had an icy surface with not very many craters and a lot of cracks in the ice, which started people wondering whether the plates could be like tectonic plates that move around relative to each other, suggesting the possibility of water under the ice, which suggested the possibility of life. Ganymede and Callisto are farther out from Jupiter, covered with craters, and a lot of these craters were deep enough that you could see ice in the craters. So that suggested that they had a lot of ice in them. Next came the Galileo mission to Jupiter, launched in 1989. And this was not a flyby mission like the others had been. This was to be an orbiter, to go into orbit around Jupiter, which it did in 1995 for 8 years, until it ran out of fuel to control its motion. And they crashed it into Jupiter to make sure it never crashed on one of Jupiter's moons and potentially contaminated it with Earth bacteria. There was a major catastrophe with this spacecraft. You can see here this blue looking thing, or purple, I don't know what color you see. It's the main antenna. It would not open. I could tell you what happened with it, but it doesn't matter. The point is, no matter what they did, they could not get the antenna to open up, which they needed for radio communications with NASA's Deep Space Network back here on Earth. Fortunately, there was a small dish antenna, which you can kind of see here. And they wound up having to send data and receive data from the Earth with this tiny little antenna, which meant they got a super weak signal, had to send the data extremely slowly, tied up NASA's Deep Space Network for huge amounts of time, communicating with the satellite, getting data back from it. When they would take a picture, there's so much data in the picture that it would take forever to transmit a picture. So they had some computer science experts develop new data compression techniques, which we still use, like JPEG, to compress images. So the spacecraft went past all 4 Galilean moons multiple times, powered by nuclear generators. And since it was an orbiter, not a flyby mission, it passed through various parts of Jupiter's magnetic fields and measured the radiation many times going around Jupiter. So we got some better information about Jupiter's magnetic field. And with better images and going closer to EO, now they could see volcanic plumes up to 300 miles above EO. Over 400 volcanoes on the surface of this moon. This is the most geologically active body in the solar system. It has mountains that in some cases are higher than those of Mount Everest. They also found that EO flexes back and forth in its elliptical orbit around Jupiter, and also when Europa passes near it, that also causes it to flex, generating heat. And amazingly, the sulfur dioxide and sulfur spewing from Eo's volcanoes is about 1 ton per second. Pretty amazing. It's a major source of high energy particles or radiation around Jupiter. They emit these gases, they get ripped apart, electrons get stripped off from them. Those electrons and the ions become radiation sources. They got a better look at Europa. It looks, I mean, if you just say, what does it look like? It looks like an icy ball with not very many craters, suggesting that this icy surface is not, it does not go back close to the beginning of the solar system. That means the surface is being re-smoothed out on a relatively short time scale. And you see all these long cracks, which starts to get people thinking that this ice is floating. What is going on here? Is floating on top of an ocean of water under it. Doesn't prove that it's so, but it certainly is suggestive. And you look at the cracks, they're darker colored, suggesting that the water, if it exists under this ice, has a lot of stuff in it. And that stuff might include nutrients for life. Some calculations, depending on how thick that water level, that water layer may be, some calculations suggest that there may be twice as much water on Europa as on Earth. I also saw a paper recently that suggested that if there is underground water on Europa, that water may undergo resonant surges back and forth in response to changes in how close Europa gets to Jupiter and to Ganymede. And of course, there are high resolution pictures of Ganymede and Callisto. Again, you can see the ice, the whitish ice under when the surface gets exposed by an impact. Surprisingly, Ganymede has a magnetic field of its own, likely implying a liquid metal core. And there's a possibility of an underground ocean under the ice on these moons. This is a little table of data I put together. Here are the moons of Jupiter moving out from the closest to Jupiter to the farthest from Jupiter. Notice the density gets lower and lower as you go away from Jupiter. The density of liquid water is 1.0 grams per cubic centimeter. So a lot of what's in these moons is probably rock and some metal that has high density. Density of rock is typically 3 to 3.5 grams per cubic centimeter. The lower this density goes, the more suggestive it is that there's a lot of water or ice in those moons. The surface gravities are fairly comparable to the surface gravity of the moon, of our moon, which is 17% of Earth gravity. Also, if you follow this arrow down from the closest moon to Jupiter to the farthest, not only is there a higher and higher water content or ice content, but less active geology as you go farther and farther from Jupiter. This shows a simple comparison for relative sizes of the Galilean moons to the Earth and to our moon. So I'd like to talk about radiation a little more. Some of you, no doubt, I'm sure know that there are belts of radiation around the Earth called the Van Allen radiation belts. There's an inner belt, which is composed mostly of protons, and an outer belt composed mostly of electrons. The irradiation gets very intense in these belts. The International Space Station orbits like this high above the Earth. So it stays out of those belts. Even so, there's a lot of radiation down here. At the top of the Earth's atmosphere, the cosmic ray density is something like 160 or 70 times what it is at sea level on the Earth. If you recall the Apollo missions from the Earth to the Moon and back, here's the proton Van Allen belt above the Earth, most intense in this region. Most of the Apollo missions took a path like this and then bent down as they approached the moon to avoid these radiation belts. One mission, Apollo 14, for some reason plowed straight through them. I don't know why. As far as I'm aware, those astronauts came through it okay, mostly because they went through it really fast. But this is a much less intense radiation than you find around Jupiter. This is a map showing distance from the center of Jupiter going this way. So 1 means the surface of Jupiter, 2 means twice as far from the center of Jupiter, and so forth. Here's Jupiter's main. Jupiter has a hard to see ring like Saturn's rings, but very few particles in it, about here. Then there's Io, Europa, and so forth, orbiting farther and farther out from Jupiter. But this radiation extends way out where these moons are. Quite intense. The electron data shown here is from the Galileo mission. The proton data is from the Juno mission that I'll mention in a few minutes. But there's a lot more to be known. As I mentioned before, there are sulfur ions, oxygen ions from sulfur dioxide coming off of Io, and many other energy particles than just these two. All of them can have a somewhat different distribution. just to give you an idea of what this means, according to one source that I read, if people in a space suit visited the surface of Europa for one day, one Earth day, half of them would die within 1 month from that radiation dose, assuming they were only exposed for one day. So it's quite intense. And that puts constraints on life on the surface of Europa. It's a pretty bad place to be, even for one-celled animals. There's a problem with getting electrical power for missions to Jupiter and beyond. As I mentioned before, sunlight gets really dim by the time you're out to Jupiter, 25 times dimmer than it is at the Earth. Nuclear-powered spacecraft are essential for a spacecraft going out beyond Jupiter. There can be, for example, no mission to explore Enceladus, or however you say it, a moon of Saturn with ice and water under it, and no more nuclear-powered Mars rovers like the two we've got on Mars right now, without more plutonium-238. This is not the kind they use for nuclear weapons. That's plutonium-239. But a lot of plutonium-238 was produced during the Cold War nuclear weapons buildup. I think about 300 kilograms of plutonium-238. It gets really hot from nuclear fission naturally occurring in it. Half-life of this isotope is about 88 years. So you surround this chunk of plutonium with something with fins and in between the chunk of plutonium and the fins, you put things that generate electricity when they're hot on one side and cooler on the other side. It's called thermoelectric generators. No moving parts, which is really nice for a spacecraft. So the US stopped making this stuff in 1988. It's now almost completely used up. I get the impression from things I've read, they might have another couple or 2 or 3 chunks of this stuff, maybe. Russia sold some to the US, but they also stopped making it, and they will no longer sell what they have left. Oak Ridge National Lab, which I think is in Tennessee, is beginning to make small amounts of it for future NASA missions. They are trying to scale up production a little bit, but it's an extremely expensive process. So the next mission to Jupiter is called Juno. It's still active. Its primary purpose was not to study the moons of Jupiter, but to study Jupiter itself. Lots of fascinating stuff they've seen. They also have been mapping out, I mean, when the Juno spacecraft makes a pass over Jupiter, they're not orbiting Jupiter at the kind of distance you see here. They come in from way out, make a fast pass past Jupiter, and then go way out again to get away from the radiation around Jupiter. But they have mapped out radiation around Jupiter. I showed you some of the data I showed you a few slides back was from the Juno spacecraft. It's also found a huge plasma current of ions flowing between Io and Jupiter, like million amp kind of currents, which is a significant sort of source of heating for Io. There's interest to find out in the future whether there's a similar loop of ions causing a plasma current to Europa or not. I don't think that's yet known. And this also causes intense auroras around the north and south poles of Jupiter. So what the Juno mission does is it has this extremely elliptical orbit, and it comes in not in the plane of these radiation belts, but kind of perpendicular to the plane and close to Jupiter, that those radiation belts don't go all the way down to the surface of Jupiter. So they kind of try to sneak in between, then back out. Out here, they have plenty of time to transmit pictures and other data back to the Earth. The electronics is heavily shielded with a titanium box around it, and the electronics is designed to be inherently radiation resistant. This was all figured out during the Cold War, how to do that. They didn't have enough plutonium-238 to power this spacecraft, so this one uses solar cells. They've got a 1/2 inch of glass on top of the solar cells to try to shield them from the worst of the radiation. They have metal, heavy metal on the back of the solar cells. Otherwise, the radiation would go right through the solar cells and degrade them from the backside. So this added a lot of mass to the spacecraft. The camera is mostly shielded. Let's see here. So Juno finished its initial mission, which lasted 2 or 3 years, and now it's on an extended mission to September 2025, unless the spacecraft gets wrecked by radiation sooner. So this shows what they're currently doing. They're making many passes past Jupiter and slowly adjusting the orbit until just last month it got down to where it went past Ganymede. Here's a picture that it took. It's going to do 2 close passes of Ganymede, and then it'll work its way down and do 3 passes past Europa and 11 past Io, plus Jupiter's rings that are even farther down. And they're not just taking pictures, they're measuring radiation around these moons. That's going to be a big deal for the upcoming missions to these moons. So there was a proposed mission, a joint NASA European Space Agency mission. The spacecraft would go out, orbit Jupiter, then the ESA part of it would separate off and go into orbit around Ganymede. The US part of it would orbit Europa. The Europeans ran out of patience with NASA back in 2011 when this mission was being planned. They said it seemed unlikely that this combined mission would ever happen given NASA's budget. So they decided to go it alone with their own Jupiter Ganymede mission that I will be describing. And after that, NASA decided to go it alone with their own Jupiter Europa mission. The ESA mission is called JUICE, Jupiter Icy Moons Explorer. Plan is to launch it next year, arrive 7 years later using 3 gravity assist flybys of Earth, 1 of Venus, 1 of Mars. If you fly past these planets in the right way, you gain speed and you can redirect your path from their gravity. The objectives of the JUICE mission are study the emergence of habitable worlds around gas giants, characterize Ganymede, Europa, and Callisto as planetary objects, and potential habitats. And then they're looking at this as a prototype of Jupiter-like exoplanets orbiting other stars. So they'll do flybys of Ganymede, Europa, and Callisto to study them and their differences. And then they want to go into orbit around Ganymede for higher resolution studies. This will include a radar for detailed mapping down to 10 kilometers depth into ice. Got a huge amount of solar cells, because even with a lot of protection over the cells, they'll degrade with time. So you need to have enough electrical power coming out of these solar cells even after they've degraded quite a bit. Just a week ago, it was announced that the Hubble telescope shows evidence of water vapor above and around Ganymede. Hubble had previously seen evidence of geysers of water from Europa. That'll be quite important because spacecraft can fly through these things and sample them. They want to explore. So the NASA mission called the Europa Clipper will concentrate on Europa. Could it have conditions suitable for life, and try to identify landing sites for a possible future Europa lander. Some of the history of this mission, time is getting on. I'll give you a little bit of it.
Yeah, we're closing right in on 10 o'clock now.
Okay, let me skip some of this stuff. So the plan is this mission will do a whole bunch of flybys of Europa, not orbiting Europa, just flying by it to reduce exposure to radiation. They looked at including a Europa lander on this mission that would detach from the main spacecraft, but that got put off to maybe the future. And again, they're using solar panels, not nuclear power. Lots of interesting instruments. They have a special radar that can go 30 kilometers into ice, deeper than the 9 kilometers that the JUICE mission can go. They have a thermal imager that will look for warmer areas on the icy surface that would indicate potential vents of water as erupting plumes into space. Some of their flybys will go as close as 16 miles to the surface to try to sample water geysers and get a better look at the surface. In some cases, they hope to get down to 0.5 meter resolution, which is about 1.5 feet. They'll also do sensitive magnetic measurements to detect underground water, and on and on and on. I wish they had a laser and altimeter like JUICE to measure bulges or flexing of the surface when Europa passes closer to Jupiter or closer to one of the other moons. There are a lot of potential add-ons that were considered, even funded people to study these other options, but ultimately none of them were selected. In summary, what we can look forward to is the European spacecraft will launch next year, arrive in 2029. It'll do flybys of the 3 outer moons of Jupiter and then orbit Ganymede for detailed study. The Europa Clipper will launch in 2024, arrive in 2030. It was originally going to launch in 2024 and arrive in 2027 if they could have used the new Space Launch System rocket that NASA is developing. Very powerful rocket. But that rocket has faced delays, causing NASA to switch to the SpaceX Falcon Heavy rocket, which is not as powerful. So they're going to do a lot of gravity assists and take almost 6 years to arrive at Jupiter. Sad to say. And my last slide, I think, yes. If all of this succeeds, I'm sure they will do some follow-up extended missions. They have to have enough fuel left and not too much radiation damage. They could obviously do more Europa flybys. maybe closer than the others, or go into orbit around Europa, do better studies, or if the JUICE mission study of Ganymede would benefit from a deeper penetrating radar study of Ganymede, the Clipper could steer and do flybys of Ganymede. Similarly, the JUICE spacecraft, one can dream that if it has enough gumption left after studying Ganymede, they might be able to move it into an orbit around Callisto. So lots of interesting stuff to come. I wish it would come sooner. Right now, the only spacecraft out there is Juno. Thank you very much.
All right, Dale, that was a comprehensive take on Jupiter and its moons. I'm excited for the upcoming missions, but I am worried about introducing critters to Europa. We have time for, I think, 2 questions. And I know Ken will had one that he wanted to ask. So Ken, if you're still out there, ask away.
Well, I wanted to just tell you about a little study that I did using Sky Safari Pro. One of the things that was interesting to me, and I'll try and keep this as brief as possible, but my sister's birthday is January the 7th, 1940, and obviously that's the anniversary of Galileo's discovery of 3 of the moons of Jupiter, and I was kind of wondering why it was that he wasn't able to see Ganymede. And when I went on the Sky Safari, I put on there, you could put any date on you want. So I went to January 7th, 1610, and noticed that, and Dale, you kind of confirmed this, that looking through his telescope was like looking through a straw. And Callisto was on the opposite side of Jupiter as Ganymede, and both of them were their farthest points from Jupiter. And he just didn't see on the 7th Ganymede. And as you said, on the 8th or the 9th, it got cloudy, and the timing may not have been right. And it did actually get relatively close to Jupiter on the 10th, but it was behind Jupiter at that time. And then finally on the 13th, he saw them together. And I think that he may have even confused Ganymede, even if he saw it with a star, because it's relatively bright. But again, why did it take until the 13th? And the discovery is actually that when Ganymede get closer, he then saw all 4 of them on the 13th. And that's where that went to. And it took a little research to do it. And it was kind of fun to do as well. The other days apparently may have had a cloud situation or something that he could not pick up Jupiter, or he just mistaken it for something else. I mean, Ganymede rather, but he mistaken it for something else. And I just thought I'd add that to your presentation. Thank you very much, Dale. It was very nice.
Thank you.
All right, and we've got a question from Gregory Frederick.
Actually, it's more of a comment. Yeah, it was a very nice presentation, Dale. I was just going to say that I believe in 2026, NASA's going to have what they call the Dragonfly mission, which is basically a drone that's going to fly over the surface of Titan and sample the soil and look for prebiotic situations on that moon, which might indicate that someday it could have life. I think it gets to Titan in the 2030s, the early 2030s. So sounds kind of interesting to see a vehicle flying, other than that little helicopter on Mars right now.
Right. Yeah, I had to narrow it down to basically a study of the Galilean moons, or as it was, I wasn't able to cover everything, but thank you for that comment.
Sure. Thanks.
Jim?
Very good. All right. So it's 10:08. Regrettably, there's no red coat to go to because we're all still virtual. I know that I missed the red coat and chilling with you all after a meeting. So let's head on out. Make sure to check out Saturn this week. And we'll see y'all on the 19th. Unless I'm like celebrating my birthday in Tahiti or something like that.
Happy birthday. That's great.
Happy
Thank you.
birthday.
Well, it's on the 19th, so that's a little early, but yes.
Okay.
Sometimes
Early birthday.
the meeting falls right on my birthday, and then it's not quite the same when it's all virtual. So see y'all later. Have a good night, and keep looking up.
Good night.
Good night.
Night all.
Dale, I'll stop the live stream.
Night.
Perfect.
Okay.
Thank you, Adrian.
Too late, already did.
Andrea,